Hi, this is Ashwin Kumar Verma. I'm here to share my third capstone project based on the mobile price range prediction. So here I have to predict the price of the phone from low cost to high cost phones, just like from Nokia 120 phone to uh, mobile phone of Apple 14 Pro Max. So this is me, and it's a self-paced project. I made it individually. This is something about me. I live in Dhanbad, BSc graduate from PK Memorial College, mm, enrolled in DS program. This is my third capstone project, and I am very much active in these three platforms. So if you want to contact me, you can contact me here easily. So let's talk about the problem statements. We have to predict the price of a mobile phone using the same test and train data by the help of linear regression, logistic regression, decision tree, etc., and also measure the accuracy level. So in this particular video, what I have done is I have taken the data and I have split into test and train data, and using the linear regression, logistic regression, and decision tree machine, I have to take the accuracy level and the machine accuracy. So workflow is in the competitive mobile phone market. Companies want to understand the sale data of mobiles phone and the factor which divides the price. The objective is to find out some relation between the features of the mobile phones. In example, RAM, internal memory, etc. And it is selling price and its selling price. It is in this problem we do not have to predict the actual price, but a price range including the how high of the prices. So totally we have to understand that we have to predict the price of any phone. So after collecting the data, it's important to understand your data. So we have mobile price prediction data which had 2000 rows and 21 columns. So let's understand the 21 column. What was that? So our 21 column is the battery power. It means the total energy of battery can store in one time measure in mAh. Blue it means Bluetooth have or not. Okay, the clock speed at which the microprocessor executes instruction. Dual SIM has a dual SIM support or not. FC front camera megapixel. 4G has 4G or not. Internal memory in gigabytes or not. M depth mobile depth in cm. Mobile width and core number of a cores of processor. PC primary camera megapixels. Px height, px resolution height, px width, px resolution width, pixel resolution width, RAM random access memory in megabytes. SCH screen height of mobile in centimeter. SCW screen width of mobile in centimeter. Talk time, longest time that a single battery charges will last when you are. 3G has or not. Touchscreen has touchscreen or not. Wi-Fi has Wi-Fi or not. Price range. This is our target variable. So this is the target variables and the value of 0, low cost, 1 medium cost, and 2 high cost, and the 3 is very high cost. Basically we have divided our target variables in three parts: a low cost mobile, medium cost, high cost, and the very high cost. The low cost we denote as 0, and medium cost we denote as 1, 2 for high cost, and 3 for very high cost. So let's see about that. Let's see the data how it is. So our data shows that the shape of this 2000 to 21 into 21. It means there are 2000 rows and 21 columns as we have discussed earlier, and the length is 2000. The column is this one. So this from this line df dot duplicated dot sum, it gives is there any duplicate rows or duplicate data or duplicate column in my data set or not. Luckily we get the 0. It means there are no any duplicates rows and columns in my data sets. So let's see the correlation matrix. It's a correlation matrix between the price range and the count. It means from this graph we can conclude that the price range of all the phones 0, 1, 2, 3 has all are in same demand. Almost same. There are slightly difference between the upper side, which we can neglect this and treat it same from 1, 2, 3, and 4. So we can see that the demand of all range of phone is equal, so all the range of a phone is equal. So let's talk about the exploratory data analysis. From this graph we can see that the battery power and the density between the phone is from 500 mgh to 2000 mgh. The demand of the battery is demand of the mobile is very high. It means uh, the people are buying phone uh, phone from the battery power from 5,500 to 2000, under 500 to 2000 battery power. So we can see that the demand is very high between the 500 to 2000. After 2000 there are very less number, so maybe they are Apple Pro Max customer or Apple customer because their phone is very much costly from other phones. So this is a Bluetooth and Bluetooth graph with price range. So here we can see that the graph is almost same. Slightly difference. The here we can see slightly difference of some data which can be in neglected. So here also we can say that the price of 0 phone and 1 phone. It means low cost and the high cost, slightly high cost phone is similar. Okay, it means Bluetooth is very much compulsory in every phone. From this graph, we can conclude. So next is the price range of with the RAM. The price range of with the RAM price is. Let's talk about the low cost. Low cost, the price range RAM is 0 to 1000. The high cost phone is 1500 to 2000, and to second high cost is approximately it is 2400, approximately 2400 to 2900 or 3000. And the very high cost phone is the RAM is very much high, 3.2 3200 to approximately 3700. So and this one is the outliers, so we can neglect this the outliers because it's very high. Most of the phone is lying between 500 to 1000, so we can neglect the outliers which is very low in number. So let's talk about the price range, PS width and density. Here we can see that the price range PS width is higher after 500 to 2000, under 2000, and after before 500 and after 2000 it's very low. It means the price range of the phone density of 500 and under between 500 and 2000, it's very high. This is the heat graph of the price range, all respective to all 21 to 21. So all the 21 columns, battery power, Bluetooth, clock speed, dual SIMs, and so on. With the battery power, Bluetooth, clock speed, and so on. This shows that the diagonally one, it means the graph between the battery power to battery power, Bluetooth to Bluetooth is one. It means uh, Bluetooth to other graph, other columns, it's differ, but Bluetooth to Bluetooth column, it's stable. Now let's generate the machine so we can predict the price. So here we can we have split our data into two parts, x and y range. So df dot drop price range and axis is equal to 1. It means df is my data frame, and here I have done that I have dropped the price range column and take all remaining all 20 column, and the price range I have given to y. So we can, because we have to predict the price range of phone. So after splitting the data, we have checked the what is my data is really separated or not. So I have checked the shape of the x and y. So we get the result here is x is 2000 into 18 and the y is the 2000. So from the first classifier, random forest. Here we call the random forest classifier, and here we can see that it's successfully came. And from this slides we can predict the date our test score, which is 0.89. So if we multiply with 100, we get the percentage. So here we can see that the 89% success rate of my data. It means the 89% efficient. I have made the machine learning. It can predict the 89% correct data. Remaining 11% are slightly error. So the test and it's a test score. Let's talk about the train score. Train score is 1. Now let's talk about the next decision tree machine learning. Here we can successfully call the decision tree classifier and y prediction and train and test. So the accuracy level we get is 0.8. It means if we can multiply with 100, we get 80% success rate. This is the evaluation matrix for the test. Now let's talk about the third machine learning, uh, linear regression. Here I have successfully called the logistic regression. And the y-pred is and the with the test and train I have concluded, and this one is my result, actual result 0. The the low cost phone is 0.78. Logistic recall is 0.83. regression F1 score is 0.81 and test set support is 374 and so on. So the weight average is the report for precision is 0.64, 0.64, 0.64 and 1600 and so on. So here is my whole project and the conclusion we get from my project is from ADA we can see that there are mobile phones in 4 price range. The number of elements in almost similar. Half of devices have Bluetooth and the half doesn't have. Is a gradual increase in the battery as the price range increases. RAM has continuous increase with the price range while moving from the low cost to very high cost. Phones are lighter RAM, better battery. Pixel played more significant roles in decision the price range of the mobile phones. From all from all the above experiment, we can conclude that the logistic regression and XGBoost with using the hyperparametric parameters we got the best result. From logistic regression we got the best result. So that's all from my sides and that's my project and I will give the link of my dataset with the GitHub link. You can easily check it out there and thank you.